Okay, you can go live. Sure, sure. You can go live. Okay. So do I have to summarize it? I don't think.
That will be better, sir. Actually,
Sir,
we
it
have-
would be really
Yes, sir.
helpful
because
if you could.
last session we had put a request, and Vishal sir had said that he will communicate to other instructor also. We are having 3 live sessions, right? So what we had requested that the first live session should be, dedicated to just snapshot of region kind of thing. Because what is happening, most of the video, not most of all the video lectures are one-way communication. So almost we get 50-60%, but whenever we are having any doubt, there is no option to, clarify it. So there is one session dedicated to just a recap kind of thing. So that will be a great help. This is just a request. So the sir had said, okay, we communicate it to all the instructors.
Sure. But as of now,
Yes,
I
sir.
didn't got any of this. If that is the case, I should have prepared one PDF. So now I should write. Okay, anyway.
Okay, now then you can plan accordingly the way you had thought of, and then we can have it on Sunday. You can communicate now at least. Do we have a session on
See,
Sunday,
today
sir?
I have no plans actually.
Okay,
so
no problem.
I was told today morning to
No Sunday.
Then, sir, please summarize
okay.
if you could.
So I thought I
Then
just come.
please.
I will ask you guys to how we proceed, and then
We'd really appreciate if you could summarize the concepts.
Okay. I will try to cover most of the lecture by lecture. Okay. Maybe that would be better. Right?
Yes.
Yes,
That
sir.
will be great, sir.
Okay.
So we are
Yes, sir.
continuing from week 2, right?
Yeah, we are starting from week 2.
Week
See,
2,
if I
lecture 1.
start revising week 1 also, that will go.
Yeah, that will go along. So I think
longer.
we should start from week 2.
Yeah, it's better starting from week 2. So I think the first lecture is like independence, right?
Yes, about independence.
Dependent random variable. So when I write variable, it is actually referring random variable. Okay. So what is random variable? Anyone?
It's a function which is mapped
So
from
random variable is a numeric value that the outcomes
can-
of
that
any
can
event
change.
can take.
Yeah.
It's a function,
Anything
which
in
is
terms of
mapping from
function?
sample space to a real line.
Correct.
Sample space to real line.
Correct. Okay. Independent
The
random
random
variable.
variables are uniformly distributed.
Random variables are
Uniformly distributed.
Not always.
No, it's not necessary that random variables
not-
should
no,
be
I
universal.
don't think uniformly.
No, it represents
Not always.
uncertainty. Like
Not always, sir.
Not always.
There is no condition on which we can say that they behave uniformly.
Okay. I can see after independence there are something related to visualization of functions. That
Yes,
those
sir.
lectures
yes,
are
sir,
actually
independent identical distributions.
Yeah,
IID.
that's important. Yeah,
IID.
IID.
IID, so can you please just summarize that?
Okay. So IIDs. So this particular I is
Independent.
Independent
And,
identity.
is
Identical.
identically
distribution.
distributed. Okay. So
Yeah.
from the names itself,
Maximum, minimum, CDF maximum, minimum.
yeah.
Wait,
So
Combination Z equal to X plus Y, X minus Y, X, Y.
This is
correct. So that is about those are comes under two variable. Is it two variable?
Yes, sir.
Yeah.
Joint PMF for
Sum of
A.
two random variables. Correct,
Yes.
correct. So that is about two random variables. So one will become
Maximum,
and
minimum.
there's some disturbance.
yeah. Please mute everyone. Please be on mute. So minimum. Okay. I will try to cover these many things as of now. We will see rest of the things later. Okay. Yeah.
Sir,
Okay.
activity questions also some doubts are there. If it would be good.
Sure. I will take So once the lecture is finished, I will take the activity question then and there itself. So if I even cover the first 4 lectures also, maybe it is better today. Maybe on Sunday I will inform the other instructor to take on from 5th lecture to the last
Yeah.
lecture. Okay.
Yes, thanks, sir.
Okay. Maybe our target. Let's keep our target to first 4 lectures of today.
So this 2 random variables, sum, max, min.
Yeah,
This
we will.
one
I will
will
try to cover. I will try to cover. If not, I will. Okay.
Sir,
Hmm.
so before you start, I have a request. Sir. It will just take 2 minutes to answer. So, regarding the extra activity peer review.
That those things I am not aware. I am not aware. Sorry.
Okay,
You
sir.
should
Okay.
ask the respective persons. Maybe Mayur, instructor Mayur, you can coordinate with him. You just have
Okay,
to-
sir. So maybe forum.
Yeah,
React forum.
So
Okay, sir.
Because sir, we are not given any guidance to do the extra activity, and we are facing a lot of trouble. So that's
okay. I will inform the team. Maybe
Yes, sir, please,
they are the
sir.
right persons to address these questions. Okay, I'm not that aware of these things.
So
Which
maybe they
may
can
waste-
have half an hour live session. That will be fine.
Okay, sure. I will inform them.
Yeah.
Okay. And before starting this lecture, I just wanted to make one quotation which I read recently, and I liked it. Hope you guys will also like it.
Your voice has gone low. Can you come?
Is it?
Yeah, now it is better.
Okay. So recently I came across some very good quotation which I liked it. So I just wanted to share it with you. So yeah, recently when I was looking at some things, and I just came across this thing. So what it says is, it is not being best, it is actually being better day by day, better than yesterday. Sorry. So this is I guess many of you or some of you might have seen this.
Yes, sir. Once the IIT topper Chitrang Maurya also said this.
Okay. So how we can relate this with our statistics course is, you may not be the best or you may not be the topper of this course, but actually what you have to try is, you just have to learn few things today, at least 5 minutes or 5-minute video lecture. Try to understand 5 minutes of video lecture, or try to understand one particular distribution, or try to solve one problem which may give you much confidence. So you should actually be better, you should become better day by day. So that is what my suggestion to you. If you wanted to, if you wanted to get good scores in statistics, or even in your life, this is one of the best quotation to follow up with. So you may not be the best in this world, but you just try to be better day by day. Okay, let's come back to our course. Okay, suppose there are 2 random variables. So I am discussing independent random variables. Suppose there are 2 random variables, x and y. X and y are random variables, and let us say tx and ty. These notations are, you are well aware, right?
Yes, sir.
Yes, sir. Yes.
Range
yes, sir.
of x and y respectively. Okay. Now we say x is independent of y if the joint distribution is equal to product of marginals for all x belongs to tx and y belongs to ty. So very simple definition, easy definition to understand. So what you have to understand is, we have a joint distribution table with us, right? So when we write the joint distribution between two random variables, we write the range of y in this side, or maybe it is in lectures, it is like this, I guess. You
X
write
and
the
Y.
you write the range of x this side 0, 1, 2, 3, 4, maybe like that, and range of y is maybe 1, 2, 3. So the joint distribution we all know. So whatever the value is present here, that is nothing but f. Okay, is this okay? Fxy 0, comma 1. So this particular value, so whatever maybe this, maybe 0.5. So this is 0.5. This fxy, this particular denotation is nothing but probability that x takes 0 at the same time y taking 1. So what is the probability that x taking 0 as well as y taking 1? So that is the probability, and in table it is denoted like this. This is the joint distribution table, and this is how we write the value. So x taking 1, y taking 1. So the probability of x, random variable x taking value 1, and the probability that y taking value 1, uska value here. So this is f xy 2, comma 1, f xy 3, comma 1. So this is how we fill the joint.
Sir, I have a general doubt.
PMF.
Sir, is there any book for better understanding of the distributions that we are doing right now, geometric and this?
Better understand.
So can we
He's asking for book.
concentrate, sir?
Yes, sir. Any
Sir, it
book
has been
that you
mentioned many
prefer?
times. Sir, it has been mentioned many times in the lecture, sir, by Andrew, sir, and it's given in the dashboard also.
Yeah, just go there.
You can please, if you can please continue with the explanation, sir.
Okay. My request is, जब मैं ये screen पे बोल रहा हूँ,
if you said this much of thing, you can directly tell me the name of the book, na?
Okay, someone post the book name in the chat box.
Sure,
Okay,
sure, I will do.
Can you go there? Can we go there?
I will do.
Okay. Okay. Okay, let's come back. So this is the joint PMF between x and y. So this is how the table will be. Once you fill the table, so this is fxy of 0, comma 1, and we compute marginals. So this is fx of x, and this will be fy of y. So when you compute the marginals, so you will be getting marginals also. So once you get the marginals with you, the product of this must be equal to this. So let me give you an example. So it's just remember, independent, x is independent of y if joint PMF is product of marginal PMFs. Okay, if the product of marginal PMFs is equal to joint PMF, then x and y are independent. So the example will be like this. So this is the joint PMF of x, y, 0, 1, 0, 1. Half. Okay, now tell me, what will be fx of x? What is the marginal?
1/4.
1/2.
Okay, this is 1/4, 1/4, 1/4, 1/4.
1/2.
1/2.
Yeah, 1/4 plus 1/4.
1/2.
The marginals, if you want x, so sum up all the y's. Okay. What you don't require, you add all those. So we require x, you add y's. So 1/4 plus 1/4, this will be 1/2. And this 1/4 plus 1/4, this is also
1/2.
This is also 1/2.
1/2.
Right. So this is fy of y. Now you see, whatever the combination you take, so fx comma fxy of 0, comma 1. So if I take this fx of fxy of 0 comma 1 is 1 by 4.
1 by 4.
Right, this is 1 by 4, and this is equal to half times half, which I can write it as fx of 0 times fy of 1.
So you have written it inverse.
Independent.
So you have written it inversely.
Inverse.
X should come there.
X should come where?
Yeah, okay.
I mean,
here it
in
Acha,
place of y in the table.
Acha, this thing, yeah, you can just
Yeah, sir.
if this is xy,
Okay.
then this will be fy of y. and
Yes.
This will be fx of x.
So,
Okay. Yeah. So yeah, so this is how this will be independent for this particular case, 0, 1 case. It should be true for all the cases. So 0, 0, 1, 0. There are 4 cases here. So it should be true for all the cases. So even if at one case, even if it fails, then we don't say that they are independent. So for that also we can have the example. Let me just give that particular example. Okay, 3, 3, 6, 7, 9. Okay, this is also independent. Okay, can you help me?
Respected sir, I have a little bit doubt. Shall I ask, sir? Sir, I wanna ask one question, sir. Let's suppose if we are checking the independent of a random variable, okay, sir, it's follow for all, sir, or it's follow for only for specific, sir. It follows all the entries in a PMF table, or for a specific variable, sir. That's my question.
For all the entries, it should be true. So product for marginal should be equal to joint PMF value.
Okay, sir. Okay, sir.
For all the entries.
For
So
all,
even if
for all
one fails, okay. This thing, I guess. This
Sir, for this thing, I think you should put one element, probability of one element as 0. I think that should work.
That should work. Correct. Yeah, this will work. Okay. Here you can see easily half times. So you can see 0, comma 0. In this case, f xy 0, comma 0 is equals to 1 by 4. But when I see the product of marginals, fx0 times fy0, this will be half times 3 by 4, which is 3 by 8. So this and this are not equal. So even if you get one particular case, even in one particular case, if your product of marginals is not equal to joint PMF, then we say x and y are independent to each other. Okay. So this is about independent. Any doubts in the activities of this first lecture?
No, sir, no.
No, I can see
Second lecture, sir.
Second
Yes,
lecture.
sir.
Yes. 1 minute.
Yes, sir.
Four questions.
Sir, IIT.
Sir, in question number 2.
Okay,
sir?
okay. Where?
The
In
first
lecture,
option.
question number 2.
Excuse me, sir.
Yes, sir. In activity 2.1,
Yes.
question number
Yes, sir.
2 and first option.
2.1.
20.
Sir, am I audible?
Audible.
Yeah. So like for to be independent, it has to be independent across the range, right? For both x variable and y random variable, right?
Right.
And so, for example, if one or two components of their range are independent, so that can we say that those two events are independent even random variable x and y are not mutually independent, but those two events are independent. Can we say?
No. See, we don't talk about independent events. Had we talked about those things?
No.
No.
Okay.
So in this
But-
lecture, we actually
No.
talk about the independence
Yes.
between two random variables. So we don't bring events into the picture. Events with independence into the
but
picture.
events can be independent on their own, right?
At that particular event, maybe you can say they are independent. No, I don't think they are independent. No.
So
No.
how do we do this? How do we check independence for large tables?
For independence event, probability of A intersection B is equals to probability of A into probability of B.
Correct.
Sir,
Hmm.
in the above calculation, on the multiplication of the two marginals,
Hmm.
you have multiplied 1 by 2. Okay. Sorry. Here is the multiplication. I had done the addition.
Oh. Okay. Okay, let us see the second question. AQ 2.1 second question.
Sir?
Hmm.
Yes,
Sir, how do we check like for large tables, sub-century large tables? It's like 5 by 5. So do we have to check for it? Is there an efficient way? Because that would be very tedious.
See, as of now in this particular course, 5 by 5, if we have given you 5 by 5, you just have to check manually. Okay. But we won't give you 5 by 5 tables.
No, I just wanted to know if there is an efficient way to do it like
Yeah, of course. When you do this further courses, no? So we have codes and everything. You can actually check two random variables are independent or not given the big data also. Even you have big data, a big range. So
Yes,
if your
sir.
X range is too large and Y range is also too large, you can actually code and you can actually directly get the answer whether they are independent or not.
Okay.
These all things
Thank you, sir.
in future, we will learn. Okay, so here it says let x1 and x2 be two discrete random variables with joint PMF fx1, x2, t1, t2 given in the table. Okay, so here what we have to do is identify the value of k first.
Yes, sir.
So how will we identify the value of k?
Summation of all the joint PMF should be equal to 1.
Should be equal to 1. So what will be the value of k?
0.
AQ 2.2.
Yes.
Question 2. So we get k equals to 0.
Yes, sir.
Okay. So once we got k equals to 0, we have values like 1 by 4, 1 by 4, 0. Okay. 1 by 16, 1 by 8, 1 by 16,
Yes, sir.
1 by 16,
1 by 8.
1 by 16.
1 by 6. Yes, sir.
So this is the table we have. T1, T2, 1, 2, 3, 1, 2, 3. Okay. So
Yes,
now
sir.
f x2 of this is T2.
T2. Okay. Okay. Yes, sir.
Okay. So what will be this? 1 by 16, 1 by 8,
6 by 6.
3 by 8. Is it 3 by 8?
Yes, sir.
So you just add 1 by 4 plus 1 by 16 plus 1 by 16.
Yes, sir.
You will get 3 by 8.
Yes.
So here we will get 1 by 4 plus 1 by 4, 1 by 2.
1 by 2.
1 by 2.
Here we will get 1 by
8.
8. Correct. Here fx1 of T1 we will get half.
1 by 2. 1 by 4.
1 by 8, 1 by 4, correct. 1 by 4, 1 by 4.
1 by 4. Yes.
Yeah, now what is the first option? fx1 of fx1 x2 of 1.
Fx of 1 and 2.
So this they are asking about this. So we
But
have
sir,
to,
no, sir, this is 2, 1. We have x1 is equal to 1 and x2 is equal to 2, no?
Will be 1, 4.
yeah. Sorry.
1, 4.
You are asking 1 comma 2. So this thing.
Yes, sir, 1 by 4.
1 by 2 times
Yeah, 1 by 4.
1 by 2. 1 by 4.
So this thing.
Yes, sir.
So for this thing, we have to product this and this. So we are going to get half times half.
Okay, okay, okay. Okay, sir.
Correct.
X1, X2,
Okay.
T1, T2 will be equals to Fx1, T1. So
Sir, you take this example, sir. Here, x1 and x2 are not independent random variables, but this event is independent.
okay. See, I don't think we talk about independence regarding events.
No, it's not. I'm just asking a question, sir. It is not about what has been told, I'm just asking a question related to the concept only. I'm not talking anything outside the concept.
Okay.
I just referring this kind of example only. You see here, the variable x1 and x2 are not at all independent of each other, right? They are not independent random variable. But this particular event, fx1, x2 is independent, correct? So it is quite possible.
See, that is what I am saying.
Yes.
So the word independence can only be talked between two random variables.
In week 0, we have talked about the word independent for events also.
Yeah, but for random variables, you can't talk about events.
Events, no.
Yeah, that's a separate case.
Separate topic.
See, you are actually bringing up that probability and those things into this play. So events, A, B events, those are different events. So when it comes to random variables, actually I don't know
Yeah,
whether
just
we can
because
say this as
they're
an event or not.
Yeah, just because their product of their probabilities is the same does not mean that they're does not mean that they are independent, right?
Correct.
So
maybe see your interpretation of thinking, your interpretation may be like this. So the product is equal to the joint. So for this particular case, I can call it as independent. That is what you want to understand, right? That is what you wanted to say. Am I correct?
I think there is a question like this also in one of the activity. There is a question like this.
Oh.
Okay, let us continue, sir. Let us continue.
Yeah. Let us continue.
If we come across this question,
then we will discuss.
We will.
Yeah, sure. Okay, let us go to next lecture. The next lecture is pretty extension of the lecture 1, where it says the product of. So where we see multiple random variables. It's not just 2. We will see some n random variables.
So that was dependent, right?
More than 2.
More than 2. Which one? Yeah, this one dependent. See, one simple logic is whenever you see 0 in your joint PMF table,
it's dependent.
The 2 random variables are dependent.
But sir, x1, x2 are not. Okay, they are dependent. Okay.
Yeah, they are dependent. So whenever you see one single entry as 0, then it is sure that both the random variables are
dependent.
Yeah. So now a little extension of what we have seen just now is when we have more random variables, not like just only 2, when we have more than 2, how we will decide the independence between the random variables. So the same logic. So the joint PMF of these n random variables must be equal to marginals. For all, this is a symbol for all. Okay, we'll write for all. X1 for all T1 belongs to, for all Ti belongs to Tx. So understand this, where I runs from 1, 2 and so on. So all the Ti should be in the range of Xi's. For all of them, this particular equation should hold. So the product of marginals, all the marginals should be equal to the joint.
This is just an
PMF.
extension of what we have written.
Just an extension of what we have seen with 2 random variables. Okay. Yeah, this is about lecture 2. The same thing and the IIDs. Now IIDs are nothing but, so we have some random variables with us. Those particular random variables should be independent. First case, first point is it should be independent.
Sorry, sir,
You mean
what should
all
be
the-
independent? The
all the
random
random
variables.
If we have random variables x1, x2, xn,
Then all the random variables should be independent.
all that means it should satisfy this condition.
Okay.
First and foremost thing is independent, and they should be identically distributed. So when I say identically distributed, their marginal PMFs are same. So identically distribution means, so whatever the distribution x1 follows, so the same distribution x2 should follow, and the same distribution x3 follows. Likewise, xn follows the same distribution. So all the x1, x2, all the random variables should follow the same distribution. So by following the same distribution,
same marginal distribution.
See, if we have the same distribution, you will get the same PMF, right? So if x1 is normal, okay, no, we don't. If x1 is binomially distributed, then the marginal PMF will be, so fx1 of x will be equal to ncx like this, right? P times x, p
Yes,
power
yes.
x, 1 minus p power n minus x. So this is the see, this fx1 of x is the PMF.
Yes, it
So
means uniform.
This is
uniform.
No, this is not uniform. See, this is the distribution of this x1. This is the PMF of this x1. The same PMF should be for the x2, x3, and so on. Xn also should follow the binomial distribution only. So the same, it should be distributed same. Identical means the same. So whatever the x1 follows, the same should be followed by x2, x3, xn, and so on. All the random variables should follow the same distribution. So if it follows the same distributions, we will get the same PMFs. So all fx1 of, so all this fx1 of t1 will be same as fx2 of t2. So not equal, will be same as fx1, fx2 of t2 will be same as fx3 of t3. All this should be following the same distribution. So identical, it should be identically distributed, as well as all of them should be independent.
This is
If
needed
this
for
is
functions, huh? This is needed for functions of random variable.
No, we are not even went for functions. This is PMF of x1.
This IID condition.
It means, sir, all all the marginals should be same.
All the marginals should be same. See, marginal PMFs are nothing but the PMFs of that particular random variable.
Yes.
Okay. If you see in the joint distribution, just connect like this. In the joint distribution, there are two random variables, and we have some joint distribution among them. So 0, 1. So let's say 1 by 4, 1 by 8, 1 by 8. So half. So 1 by 8, 1 by 4, 1 by 8. So this is just the joint distribution of xy. So when I compute the marginals, what happens, you know? So this fy of y will be half. This fx of x will be 1 by 8, 3 by 8, 3 by 8, 1 by 4. Okay. So once you have the marginals with you, if you see separately this fx of x, so this fx of 1 3 by 8, fx of 2 is 3 by 8, and this fx of 3 is 1 by 4. This is actually the PMF of x. So probability mass function of x will be this. If you separately look at only the random variable x, It is nothing but the PMF of X. So the marginal of the marginal PMF is nothing but the PMF of X if you look at it separately. So if you don't involve Y, so this is PMF of X. So in the same way, PMF of Y will be half for Y is equals to 0, 1. Like this. So is it 0, 1, 2? Okay.
Yes, 0, 2.
Okay, try to understand. When we talk about combinedly, we say marginal
Sir, it should be
PMF.
2.
Okay. When we talk about these random variables X and Y combinedly, then we talk about joint, marginal, and conditional. So if you wanted to see separately, so once you compute the marginals and if you see separately X as a separate random variable and Y as a separate random variable, you can actually say that particular marginal PMF is nothing but the PMF of X. Okay. So here IIDs means it should be all the X1, X2 and so on Xn's must be independent first of all. That means this condition should be satisfied. And nextly, whatever the distribution X1 follows, the same distribution should be followed by X2, X3 and so on Xn. So all of them should follow the same distribution. For example, in the lecture also, I guess, I don't know whether this is discussed. So I am tossing a coin. Okay, I am tossing a coin 10 times. And the first time, so I am defining a random variable X such that it takes 0 if it is head, if it is tail, it takes 1 if it is head. Okay, and out of this 10 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first time, so whatever the value comes is a random variable. So what will be the output if we don't know? It may be tail, it may be head. It is random variable. So I denote this random variable as X1. So X1 can take either 0 or 1, right? X1, if the first toss is tail, it takes 0. If the first toss is head, it takes 1. Similarly, the second time toss denotes X2, X3, X4 like this. I defined X5, X6, X7, X8, X9 and X10. So if you see, X1 is a Bernoulli random variable. Agreed?
Yes, because there is only two outcomes.
Yeah, Bernoulli with let us say it is a fair coin. So it will be Bernoulli 0.5. In the same way, if you see, the second toss will actually be independent of the first toss. If the first toss is head, you cannot guarantee that the second time also will be head or second time will be reverse of the tail. You cannot guarantee that, right? All of them are independent to each other. So in this particular case, X1 is independent of X2, X2 is independent of X3. You see them as you see them as the events. So first event is like first time tossing the coin. So first time tossing coin is definitely independent of the second time you toss the coin. And those two are independent of the third time you toss the coin, right? So these all are independent firstly. And nextly, X1 follows Bernoulli. If X1 is following Bernoulli, even the same holds for X2, X3, X4 and also X10. All of them follow the same, whatever the X1 is following distribution, all of them will follow Bernoulli 0.5. And the PMF will be
So does that means all the variables not only will have same type of distribution, they will also have the same parameter value. Is it that way?
Yes, identically distribution means the same thing. So the mean will be same.
Okay, so if X1 is having Bernoulli 0.5, the others also will have will also be having Bernoulli 0.5 only.
Bernoulli 0.5, correct.
Okay, okay, thanks.
Yeah. So where T1 is 0. So this is the PMF of X1. The same PMF is for X2, X3, X4, X5 and so on, X10. And this is actually called as marginal PMFs. So these marginal PMFs are same for X1, X2, X3, X4, X5 and so on, like Xn. So we can ask you questions like, so how many times, what is the probability that 5?
Sorry to interrupt, just one question. So if we are tossing the coin, I'm sorry, this is basic and but if we are tossing it for 10 times, I understand that each toss is a Bernoulli, but when you toss it 10 times, does it not tend towards a binomial? Can we not
Okay, that
approximate
is,
it to a binomial?
yeah, that is, if you wanted to look it in that way, then that will be binomial. So I just wanted to, but if you see in deeper, much deeper, before going to binomial only, if you see in deeper within these 10 tosses, by looking at each toss, they are actually independent Bernoullis.
Okay, okay. So is it safe to say like these independent Bernoullis will someday add up to a binomial, correct?
But not someday, it will add up to binomial.
Okay, okay, okay.
Yeah.
I have a question. If you can scroll up a little above in the previous table, you have given it here as PMF of X is the one that you put it in the bracket, but that is if Y is equal to 0, is it? Sorry, Y is equal to 1. Which one is that?
No. Okay, this looks like 1 by 8, is it? These are 3 by 8. 3 by 8, 1 by 4. So this is this one. Whatever I wrote is this one.
Okay. All right.
This is sum of these two, these two, these two.
These are not
Okay,
same.
it is nothing to take with Y. Okay. Even the Y is 0 or Y is 1.
Okay.
The fx of 0 will be 3 by 8. So if Y is 0, it will be 1 by 4. If Y is 1, it will be 1 by 8. But if Y is either of 0 or 1, then my f of x of 0 will be 3 by 8. It is just a
These
sum
are not
of
same, sir. Like fx0, fx1, fx2 are not same.
Maybe it may not be same.
Just now we were
This was not an
discussing
example for the
all PMF
IDD,
should be
right?
same.
So
All PMF should be same. Right now we were discussing that for x1, x2, x3. Just now we were discussing that all PMF should be same, like for x1.
This is not. This is nothing to do with IIDs. This is different.
this was just to explain the PMF.
PMF. Why? How actually that marginal PMF can also be looked at as a PMF of x. For that, I just gave an example. Actually, marginal PMFs are nothing but the PMFs of those random variables independently. Okay. Now, this is actually, I just wanted to give an example of IIDs, how the IID samples looks like. So, a small example. In the lectures, there are more examples, I guess. But this is a small example where there are some 10 random variables which are independent to each other. And also all those 10 random variables follow the same distribution. So these particular 10 random variables x1, x2, x10 are IID samples. So how we represent is x1 to x10 actually follow IID Bernoulli 0.5, or I just defined a random variable x as Bernoulli 0.5. I can simply write in place of this Bernoulli 0.5, I say it follows IID x. Okay. So this is what IID means. These are nothing but independent, identically distributed. Okay. Now go back, watch the lecture. See, if you watch the lectures, I hope Andrew sir was explaining very clear with quite a lot of motivation, and examples are also very good. So just watch. If you are not able to understand in 1x speed, just make yourself comfortable going very slow. Maybe you can use 0.5 speed or 0.75 if you are not able to understand quickly. Just take your time.
Where we are struggling is applying these concepts to solve the problem. The lectures are very good and we are able to catch it there. But when applying these principles in the assignments, that's where our struggle is coming in.
Okay.
Yes,
Okay.
sir,
Then
the
we will
questions
discuss.
are
See,
slightly difficult.
that is why we can discuss it here, right? So I will give you ideas to solve. Okay. Now that we have finished lecture 2, let us go to activity questions of lecture 2.
The third question.
Okay. Third question. Any other?
First also, sir, like first there are two options. Last option is okay. How the other option is coming, because that part is not discussed. Or maybe I didn't understand that.
Okay. So let me share that screen then. This is an hello, am I in the call?
Yes, sir.
Yes, sir.
Can't I stop the sharing? So its screen is visible.
No, sir.
Screen is not visible, is it?
No,
Yes,
sir.
No,
the
sir,
screen
it's
is
not
not
visible.
visible.
What happened to this? Just a second. Okay. Okay, is it visible now?
Yes, sir.
Yes, sir.
Right. Okay. Okay, you're asking about the first question, right? Okay.
Yes, sir. First question, there are two options. Last option is okay, like it's being discussed. How the first option is coming, and third question, I'm not getting the answer.
Okay. So you know conditional distribution, right? For two
Yes, yes.
random variables. Is it done in first lecture?
Yes,
First
yes.
week, right?
Yes,
Yeah.
yes.
So
Yes,
when now you tell me when two random variables are independent, we will come and deal with two random variables first. You tell me when two random variables are independent, what will be the conditional distribution of x1 over x2?
It will be same as x1.
It will be
Same as x1.
The
same as
condition is
x1.
valueless.
Yeah, correct. So if one is independent of other, so that says that x1, whatever the x1 values takes, it is independent of what x2 takes. Okay. What is conditional distribution? So if one random variable is taking one value or one random variable is behaving some kind of thing, on condition to that, how is the other random variable probability is changing? Correct?
yes, sir.
Yes, sir.
Yes,
Correct?
sir.
Now, if both the random variables are independent, what makes sense to talk about conditional distribution between those two random variables?
No sense, sir.
No, right? So that means what it means is f x1 such that or x1 slash x2 taking some value is nothing but fx1. So it is nothing but the PMF of fx1. So it behaves same. It is independent of x2. Okay. So now if you want to see it in three random variable case, now see it is given that x1, x2 and x3 are independent random variables. Okay. Now whatever x1 random variable takes, it is independent
It's
of
x,
x2, x3.
sir.
Hmm?
It's just x.
Which one is x?
Is
No,
it
we are
x
talking
or
about the
x1?
first option.
Okay, okay.
Okay. If x1, x2, x3 are given as independent, so whatever the x1 value takes is independent of x2, x3. Can you mute? Whatever the x2 takes, it is independent of x1 and x3, like this. So now, whatever the joint PMF x1, x2 takes, that is independent of x3. Correct?
Yes, sir.
Yes, sir.
Correct. So whatever the joint distribution is, see this fx1 x2 given x3 is equals to t3 of t1 t2 is nothing but fx1 x2 of t1 t2. Joint PMF of x1 x2 that will be equal to the
So we
joint
can
PMF.
say like if any number of independent random variables are there, then this joint doesn't make any sense.
No, joint makes sense. Conditional doesn't make any sense.
Sorry, conditional doesn't make any sense.
You can actually remove that conditional part directly. So that fx1 x2 given x3 is equals to t3, you can actually replace it with x1 x2. Okay.
Yeah, understood.
Now you know it is, if it is independent, then the product of the joint PMF will be the product of marginals. So you can write it like this. So there will be an intermediate step in between. That's it.
Okay. Okay, sir.
Okay. Yeah. And what is the other one?
Third question, sir.
Third question, is it? Okay. A random experiment consists of rolling a fair die until 6 appears. Let x denote the number of times the die is rolled. Suppose 6 does not appear until the 6th throw. Find the probability that the 6 will appear after the 8th throw of the dice. So yeah, in between there is one more thing discussed in this lecture, which is called memoryless property.
Yes, sir.
Have anyone of
Memoryless
you?
property. Yeah.
So you should use that memoryless property here.
Memoryless property of a geometric.
That it will be 1 by
Geometric
6 to the power 8 or 1 to the power of 6.
So answer is
Sorry,
coming
2.
as 5 by 6 to the power 2.
Yeah.
So, but if we use this directly, this IID, that is 1 minus p to the power j, it's coming 5 by 6 to the power 8.
Also have to divide with 5 by 6 to the power 6.
Why so?
Why so? Because
because it is conditional. It is
yeah,
given
it is
that
conditional. Yeah.
You have to find
So you have
x
to
greater
divide.
than 8 given x greater than 6.
So the condition is probability of x greater than 8.
Can you do this
given
one?
That the x is greater than 6.
So please solve this problem.
Okay. AQ 2.2 question 3. So this says actually x is geometric 1 by 6. Correct. This you guys convinced? So x is actually the random variable. Am I audible?
Yes.
Yes, yes.
Yes, sir.
Okay. So x is a random variable that takes sorry. What is x? Yeah. X denotes the number of times the die is rolled until 6 appears. So we will, our success is 6 appearing. So what is the probability of success? 1 by 6.
1 by 6.
And we will roll the die till the first success occurs. So it is geometric. We know this. Now the next thing is we should use the memoryless property that we will get to know from the statement. Suppose 6 does not appear until the 6th throw. It is already said that we know that 6 is not appearing until the 6th throw. Find the probability that 6 will appear after the 8th throw. So that means we need probability that x is greater than 8. X is greater than 8 means x is actually denoting the number of times I should throw the die. Number of times I should throw the die. So this is actually greater than 8. So that is what we need. Given that x is actually greater than 6. Because already 6 throws are done and 6 never appeared. So x is going to be greater than 6. But we need probability that x is greater than 8. So this is nothing but x greater than 6 plus 2, given that x is greater than 6, right? This is nothing but equal to a probability
Got
that
it,
x is
sir.
greater
Got
than
it.
2. Correct?
Yeah, got it, sir.
You should use the memory less property. This is called mem.
So, like that is the problem, sir. Understanding and then
can you
matching with the
go ahead?
activity.
I mean,
Here,
yeah.
From here it is like 1 minus of probability that x is less than or equal to 6. So 1 minus probability that x is equal to 0 plus.
Okay. Okay.
You can compute, I guess.
Yes,
So you
yes.
know the geometry. Done. So what will you get?
Can I ask one question here? When we see geometric, it is, of course, normally seen as a number of times something has to be done for achieving a success. So when we see x is greater than 0, that is to actually assume that it is geometric, or is there a limitation on what we can assume? If I see x1 is greater than 0, like greater than 10, like in the problem from assignment 2, the activity 2, problem 2. It says x1 greater than 10, x2 greater than 10, x3 greater than 10, everything greater than 10. So even if the geometric is not given, can I actually assume that because it is greater than 10 that is being asked, it tends to be geometric, or it's not?
No.
Okay.
No, it is not always true.
Okay.
See, there will be some unknown distributions, like if I can recall some, there will be some Bell distribution, something V Bell or something distribution. So there are, we know only 5 or 6 distributions as of now, right?
Right.
There are some 15 or 20 distributions.
Oh.
Okay. So
For
it
discrete
may
only,
fall
sir.
in those distributions also.
Or for discrete only.
No, not for discrete.
So in the same, can you actually just explain the second one also?
Second one, x1 to x10 IID
No.
geometry.
No. Activity question 2.2, question 2.
See, that is what x1, x2 to x10 IID geometric 1 by 5. Find the probability that x1 greater than 10.
Yes.
Yes. Okay. So would anyone like to answer his query? Or shall
So actually, I've solved a question, but I just want to confirm it. So basically, there are 10 variable x. Therefore, we are doing 1 minus p raised to n and again raised to 10. So it is 1 minus p raised to 10 raised to 10. Therefore, it is 0.8 raised to 100, right?
Yeah.
10 into j.
Yeah.
10 into 10, 100.
Correct. Okay, come over here. What is the doubt? You just want to confirm
This
whether
was
you
the
are
doubt.
doing
I just
correct.
wanted to confirm whether that is the only reason why it is raised to 100, or is there anything other?
Yeah, see, 10 random variables are there that will go for power, and उसके बाद और एक power 10. Correct. Yeah, that's it, I guess. 0.8 times whole power 10, and this will be 1 minus 1 by 5. Yeah, 1 minus summation to I to 1 to 5. Yeah, it will, inside one will come to 0.5 whole power 10, 0.8 whole power 10, whole power 10. Yeah, 100.
And that will be again 10 times, right?
Correct.
Okay, sir. Thank you.
Sir, can you please show calculations on the screen?
Yes, please.
Okay, shall I do that?
Yes. So this geometric
Yes,
1
sir,
by
please.
5 is representing the probability of what? What is that 1 by 5?
Probability of getting success.
Okay.
Right? Probability of getting the success. So we are wishing to get the first success.
In this
But what is
problem,
success defined as? Is success defined as
See,
like, you
that
know?
depends on the how we define our success. See, if you are throwing a die, if you throw a die until you get some 2, so getting 2 on the die is a success, and getting
Understood.
every other things is failure. Or if you wish to
in this problem, the
So then if I defined x1 greater than 10 is my success event, then it
Hmm.
will be 1 by 5 to the power 10, right? Which is 0.2 to the power 10. If I define my success to be x to be greater than 10. X1.
X to be greater than 10.
X1 to be greater than 10, x2 to be greater than 10, and x10 to be greater than 10. Then it would simply be 1.5 times multiplied 10 times, correct? Or sorry, if it is geometric, then it is 1 minus p.
Yeah.
I'm sorry, I don't remember.
1 minus, it will be something like this. 1 by 5, 2 by 5 whole power. Okay, 1 by 5 plus 1 by 5 into 2 by 5 whole.
This should be 1 minus p to the power k minus 1 into p. So,
shall I ask a question, sir?
Sir, why we are not using direct formula, sir? 1 minus p upon.
Yes, sir. Why
J?
we are not
Yeah.
using 1 minus p by j?
Yeah.
Power j.
1
1
minus
minus p power n into j. Here n is 10 and j is the.
Yes. Yeah.
Yeah, this one.
Acha, is this a direct formula?
This is a direct
Yes, sir.
formula. You don't have to go
Sir,
through all this.
if you do the summation, it
I
cancels
mean,
out
convert
and
like
come
this.
to
Okay,
this.
okay.
The end
See, I
product
am
will be
bad
this
at
formula.
remembering formulas, so that is why.
Maybe it's a good idea to understand why the formula comes, no?
Yeah.
Yeah.
Yeah, but for application, you can do this formula.
You can.
Oh yeah. You're right about the
You
application
can
part.
do it by yourself and come to this formula.
Okay.
Yes.
Just try it like this. So my approach will be very straight from basic. So I will just convert this particular thing like this. This will be whole to the power 10. And later what I will do is inside I will convert like this. And 10. And this will be like summation. You see, this will be a summation, and it will, this 1 and 1 will get cancelled, and ultimately it will remain something like 0.8 to the power over 10. Okay, if you want this expansion, it is just simple. This is x1 taking 0 minus p1, x1 taking 1, and so on, x1 taking 10. This whole power 10. So this is nothing but p1, sorry, 1. This is 1, 2. So probability getting in the first trial itself. So the probability will be 1 by 5 minus 1 by 5 into 2 by 5 minus 1 by 5 into 2 by 5 square, like this, minus 1 by 5 into 2 by 5 whole power 9. This is to the power 10, like this. 1 minus, this is a geometric progression. If you know geometric progression, you can sum it up.
So where did the 2 by 5 come from?
Sorry, this is 4 by 5.
Oh, okay.
Probability of failure.
Probability of failure.
Okay, this is 4 by 5, and the summation will be 1 by 5 so 1 e to the power
So we
5.
still don't know what success is defined as, right, in this problem. I'm afraid
Success is the.
See, success
is defined
as
x1 greater than 10.
success.
The given number is greater than 10.
Yeah.
x1 greater than 10. Okay.
Yeah.
Not x1, x greater than 10.
No, x greater than 10.
Yeah.
Okay. Okay. Thanks.
So you just use the geometric progression here. Okay. You know this, right? A plus AR plus AR square. and so on a r to
Yes,
the
sir.
power n. You know this? You can take out a common, 1 plus r to the power n. This will be r to the power n plus 1 minus 1 by r minus 1. Okay, use this formula. Here r is nothing but 4 by 5. Okay, so use that formula. You will directly get what is the formula, 1 minus p whole power nj. Is it?
Yes.
Yes, sir.
What is j? This number of
J is the number of.
this na
Yeah.
10. So we will get 1 minus 1 by 5 to the power 10,
10 into 10.
10 into 10.
Ah.
Okay, this is 0.8 times 100.
100.
So if you see, if you struck or if you forget formulas, just go with basics. Okay, even
Yes.
though you may run out of a few minutes, but ultimately you will get the correct answer. Instead of this 1 minus p to the power nj, if you are doing n by j, you will lose the marks. Okay, if you have time, see, try to remember the formulas. I don't say anything about that. Even though if you forget about the formulas, go through the basics. So how to convert this, how to write this like this. Okay. Okay, cool. Okay, next topic is like visualizing functions of one random variable, one-to-one functions.
Yes, sir.
So, do I have to discuss that too? Like I don't. So it is basically, it is saying that if my new random variable is a function of one of the other random variable, how will that random variable behave? Okay, so what it says is, I know a random variable that takes uniformly -1, 0, 1, let us say. So when I say uniformly, the probability of this, take one more. Probability of this will be 1 by 4, 1 by 4, 1 by 4, 1 by 4. I know how x behaves. For suppose if there is a new random variable y, which is a function of x, and also a one-to-one function of x. So in mathematics now you should be able to tell what is one-to-one function. What happened? 9:30 हो गया, नींद आ रहा है क्या सबको?
One input,
When
one output.
one input has one output, that is a one-to-one
That
function.
one input maps to one output.
One function.
One-to-one function.
One input gives only one output.
Correct.
Sir, every input in domain gives an identical output in subdomain.
Distinct output.
Yes,
not
ma'am.
identical.
Oh, sorry,
Distinct, not identical.
If your inputs are different, so if your x1 is different from x2, then f of x1 must be different from f of x2. So that is what one-to-one function says. So those functions we know, right? Straight lines are one-to-one functions. Exponential functions are one-to-one functions. Correct? So those are the examples which were also discussed in the lecture. So now I do new random.
Monotonically increasing, decreasing.
Yeah.
Monotonic.
Monotonically
Monotonic
increasing
function.
or monotonically decreasing. Yeah, those functions are one-to-one functions. And in this particular course, we deal with most probably the straight lines or the exponential functions. In the lecture also, it is given 2 power x and x minus 5. So let us see one of it. So what it says is, if there is a new random variable y, which is a function of x, which is a one-to-one function of x, like this, x plus 1. Now if I wanted to look at the distribution of y, how is it behaving? If I wanted to see, we draw a table where we keep x, we keep the probability of x is equals to x, which is fx of x, and we compute the y. Okay, when x is -1, when x is 0, when x is 1, when x is 2. Okay, I have given equal probability. But let me change it. So when x is minus 1, the probability that x is equals to minus 1 will be 1 by 4. The probability that x is equals to 0 will be half, 1 by 8, and this is 1 by 8. Now, first and foremost thing is you have to find the range. When x is minus 1, what will the value of y?
0.
0. Just substitute minus 1 in this function. 1-to-1 function. 0. When x is 0,
1.
1.
1, 2,
2, 3.
3. Now you see, probability that y is equals to 0 will be
1 by 4.
okay.
Yes.
This is what this is actually the translation. So if you see, if you wanted to draw the graph of PMF of x, so it will be like this. So minus 1, 0, 1, 2, and it will be 1 by 4 here. For 0, it will be half here. 1 by 8, 1 by 8. So this is how the PMF will be. This is how the PMF of x will be. If I look at the PMF of y, if I look at the PMF of y, it will be translated. Just it will translate the same thing will be shifted 1 unit to the right side.
1 unit to right.
Yeah, 1 unit to the right side. So just 1 unit to the right side, it will translate. The same PMF will hold, but it will now that if you see the graph, it will be shifted 1 unit to the right side. But the same properties will hold, the same probabilities will hold. It will look almost the same thing, but on plane or on visually, if you wanted to look at the PMF, it will be shifted 1 unit to the right side of what the random variable x PMF is. Okay, so this is about the visualization of random variables, new random variables, which are functions of well-known random variables.
Sir, one basic doubt, sir.
Hmm.
Like when we convert it into a function, like to the power x or y, shape of the distribution changes, right?
That shape of the distribution changes when it comes to 2 to the power x.
But the underlying nature of the distribution or underlying nature of the underlying property of the distribution remains the same. So my question is then why do we take it into the function form?
Why do we take it in the function form? See.
Yes.
Yeah, good question.
Might be that we are going to study, in further process or what? What is the purpose of converting?
No. See, always the data won't be how you think, right? It might be maximized or it might be exponentialized. It might be in the different form. Okay. So it may not always be like this particular data is actually taking value 1 with probability 0.5, value 2 with probability 0.5. It may not be like that always. Okay. Also, the random variable may not take the consecutive values. In your data, sometimes random variable takes value 1, but it may never take value 2. That also we know. It will never take value 2. And it will take value 4. It will take value 8. It will take value 16. Like that. If your range is different, if your random variable range is different and you don't know how to fit that particular data, you don't know how it is distributed. In those cases, we actually see that it is a exponentially distributed function. It is actually a function of one random variable. So then we will convert it like that.
The underlying nature remains the same. Even after transformation, underlying nature remains the same.
Yeah, but how do you identify it? See, I have given you like this.
Okay, let me add one more component to it, sir. Like when we took 2 to the power x, right? So sometimes it was appearing, positive skewed or negative skewed, right?
Negative skewed.
Yes, yes, sir. In one of the graph, it was negatively skewed, like on the left-hand side, more data were concentrated, and in some of the graph, more data were concentrated on the right-hand side. Correct. So I may interpret it wrongly also. It may be that my data is not uniformly distributed, but while after transforming, it is giving a different picture altogether. Shape-wise, I'm saying shape-wise. If I'm trying to draw any inference with respect to shape of the distribution, so I may get a different interpretation in that case.
Okay, it is left skewed.
Right. Left skewed and right skewed.
Which one is right skewed? I haven't seen right skewed here. See, 2 power x is a left skewed one.
Left skewed.
Yes, okay, let us take left skewed itself. So all the data are coming to left hand side right now. But earlier it was uniformly distributed.
Let us take x cube, is it?
Okay.
No, what you said, which one we should take?
Left skewed.
Okay, left skewed, okay.
Earlier my data was, before transformation, it was uniformly distributed, right? But while carrying out the transformation, now my shape has changed and it is appearing as left skewed, right? So after transformation, I may interpret it wrongly. It may happen. And my objective is that why do we transform it? That is my question.
No, we are transforming just to understand the behavior. See, if you see the below, if you see the left skewed graph, can you able to find out which distribution is it following?
No.
Straight away, if I have given you the below graph.
Which graph?
So this 2 power x thing, if you have your laptop, just open 2.3 lecture. Okay, let me show you here. Okay, you see here, here the below graph is a left skewed graph, right?
Correct.
Now, if you straight away in your real life, when you're dealing with real data, straight away if you have seen data like this, so what are your conclusions? What will be your conclusions?
It is clear that it is still uniformly distributed, right?
How do you know it is uniformly distributed? Yeah, it is uniformly distributed.
It is uniformly.
Because height of the bars are same.
Height of the bars are same. Yeah, it is uniformly distributed.
Correct. Based on
right.
that, I am saying.
Based on that, you will say, see, how will you interpret it? Will you take these values like this itself? Like your random variables are taking, let's say, from 0 to somewhere around 2 power 10, 1024.
Correct. It is transformed value.
It
is transformed value. Like when I'm taking 2 to the power 10, that gives me 1024, right? 2 to the power 10 gives me 1024. It means my earlier random variable was 10.
See, now you are coming from top to bottom. I said you have seen the very data which you are seeing the below one. You don't know the top one.
Okay.
Your data is the below one. Okay. Will you be interested to deal with data which has a large range, wide range, not the large range also, wide range. It starts from 0 and it is still 1024. And in between, you don't have any values. Few values are not even the random variable is taking. So
no,
will you keep the data as it is?
I would not like to deal with that.
You would not like to do it like that, right? You will transform that thing back to this X uniform 0 to 10. And then you will look the data very closer, right? It is very, these functions are useful. to look at the data visually. Okay, to deal the data very easily. And if one sees the data, if one sees the two graphs, which graph will he understand more clearly?
The top one.
Top one, right?
Yes.
So from the below one to top one, how will you go? Without knowing this function, without knowing this particular random variable can actually be transformed back to X.
Here it is exponential, then I will take log.
Yeah, that is why you will take log. Y is equals to 2 power x, you will take log of it.
Correct.
And it will become the above one. Correct? Okay. Maybe this is one usage. I may not recall it. See, there, these functions and everything, you will see it even in your degree level courses. Okay, it's not it will not end at diploma. Even if you will see this at degree courses. Okay, everything you can actually convert to a function, and by converting function you can actually simplify the things, and you can actually visually look at what is happening in 2D. Okay.
But while converting into function, the underlying nature doesn't change, right?
Underlying nature doesn't change.
Okay.
Yeah. And let's come back.
കുറച്ച് വെള്ളം തരുമോ എനിക്ക്?
Sir, are you there? Hello, sir, are you there?
No.
Hello? Am I audible?
Yes, sir.
Yes, you are. Yes.
Yes, sir, you are audible.
Sorry, I suddenly
Yes, sir.
disconnected. I don't.
Yes, sir.
Just a second. Okay, so yeah, we are discussing about one functions, right? So that is one usage of why we convert functions, look at functions of random variables. Okay. Okay. Who asked that question?
Yes, sir, myself.
Yeah,
Yes, got it, sir.
Yeah. Okay. Okay. If it is 1, 1, you have the range here the range will be unique. So whatever the value you get here, it will be always different from the other. If it is 1 1, if it is many to one, we know many to one, right? Which are not 1 to 1 functions, which are basically when y is equals to x square, y is equals to x into x minus 1 or x plus 1. So this is a quadratic. This is a quadratic. Like this. This case, these kind of functions are many to one functions in which two different values gives me the same output. So in this case, even when x is minus 1 or when x is plus 1, x takes plus 1, my y value remains 1. So we get in this particular table, we get repeated values in this third column. So if I take an example here itself, so let us see y is equals to x square is my function. Okay. And yeah, this particular y is equals to x square is most important when you deal with chi-square distribution. Okay. Normal.
Which one, sir?
This is y is equals to x square. Is important if your x is normal.
Poisson.
If x is normal, you will deal with this. Just for your idea why we study these things is when x is normal, y will be chi-square distribution with n degrees of freedom, n minus 1 degrees of freedom. Okay, you will deal with all this. If other people are worried about what all these things, you don't need to worry about.
Do we have chi-square distribution?
Yeah, we will study chi-square distribution in the later of the course. Okay, so that is where this is helpful. See, this y is equals to x square. Both of them follow a well-known standard distributions, y and x both. So one is normal and another one is chi-square. Chi-square.
Chi-square.
Okay. Yeah, chi-square. I guess chi-square only, or it is beta. No, chi-square. Chi-square is one. Okay. Anyway, both are both the distributions will be standard, well-known distributions, and we will deal with those distributions in week 7 or week 8. Okay, so this let's come back dealing with this many to one functions. So y is equals to x square is one function which is many to one. Now if my x values are varying from -1, 0, 1, and this is 1 by 8, this is 1 by 4, and this is 5 by 8. Okay, let us say it is like that. Okay, let me give. Okay, it is fine. Now let's draw the table. So x takes -1, 0, 1. Similarly, the probability is 1 by 8, 1 by 4, 5 by 8. Now if you see when x is -1, y will be y is equals to x square is the function.
1.
1. When x is 0?
0.
0.
When x is 1?
1.
Now you see 1 is repeated twice. So
Yeah.
y random variable taking value 1 has two chances now. Either x is -1 or x is 1. So the probability
6 by 8.
will be
6 by 8.
That is
the probability will be added.
Added.
So 1 by 8 plus 5 by 8. So this 1 by 8 is when x is -1, and this 5 by 8 is when x is plus 1. So in both the cases, y value will be 1. So the probability of y is equals to 1 will be 1 by 8 plus 5 by 8. And the probability that y is equals to 0 will be 1 by 4. So this will be 3 by 4. Okay. This is how we calculate the probabilities of the new random variables, which are function of the well-known random variable. Okay. Any doubts in this AQ?
Sir, 2.4 last question.
Yeah, same.
2.4.
Fourth question.
Fourth question.
Yeah. X is geometric T and f of x is x by 2. Okay, maybe after dealing this question, we can have some general questions and we will take a leave for today. And most probably we will try to meet on Sunday. Okay. Is that fine? Or any other
Yes,
questions are also there? Okay, I will take
Yes,
another
sir.
15 minutes. It's fine.
I have one doubt in graded assignment 1.
Okay. Sure. We will deal that within, maybe we will try to finish within 15 minutes. 20 to 15 we will try to finish. Geometric T, and it is given that f of x is equals to x by 2 when x is even. Right.
Yes, sir.
X plus 1 by 2 when x is
And X is odd.
Okay. Now what we need is f of x taking value k. Okay. Now you have to see here what is the range of f of x. So let me define this particular f of x is on y. This y. Okay. What is range of y? What will be the range of y?
So it will be the whole
1 to
net,
infinity.
1, 2, 3 till so on.
1, 2, 3 and so on to infinite.
Till
Correct.
infinite.
So in between there will be k, somewhere k, right?
Yes.
Yes, sir.
So y taking k.
Do we take 0 or not here in the range?
No.
No, 0 is not possible, right?
Because if the number is even, we will get answer as a means we will get
Zero is even number, na?
0 is
Zero
also an
X
even number, right?
Zero is
X
even.
can't be
even. But
zero can't be in the range of
yeah,
y.
what is the
Yeah.
range of tx? It will start from 1 to
1 to
That's
infinity.
why.
Yeah.
yeah, x
Okay.
x value of
Now
x
now
starts
okay.
from yeah.
Dx means geometric progression, right?
Yeah, it is given as geometric progression and
Okay,
it
so
starts from 1.
okay, the range of geometric progression starts from 1. That is the reason why we are not taking 0, right?
Right.
Yeah.
Yes.
We need probability that y is equals to k. Now observe, this k I can obtain. So if x is even, two cases, right? If x is even and x is odd. So I can get k from x is even and also I can get k from x is odd.
X is odd.
Okay. When x is even, x by 2 is equals to k. What will be x?
2k.
2k.
From here. And from here, when x plus 1 by 2 is k, what is x?
2k plus 1.
2k minus 1.
Minus 1.
Sorry,
That
minus 1.
means this probability that y is equals to k is equal to probability that x taking 2k plus probability that x taking 2k minus 1. See here above itself we have done this many to one functions. So in order to compute the probability that y taking 1, we have taken all the cases y takes, right?
Yes.
Minus 1 case and plus 1 case. Now even here also probability that y is taking k, we have two ways to take y takes k. Either x is 2k or x is 2k minus 1. So in both the cases, see here 2k is an even number. So you take k anything, 2k will be an even number. In the same way, 2k minus 1 is also an odd number.
Odd.
Okay. So in these two cases, we will get probability that y will be equal to k. So if you are confusing with this thing, let's go back to f of x only. So this is what the question is. So now we know probability that x is equals to 2k. So when x is geometric p, probability that x is equals to 2k will be
1 minus p raised
1
to
minus p raised to 2k.
1 minus p raised to 2k minus 1 times p. Correct?
Yes.
2k minus 1.
See,
So
when
you said
probability
x
that
equal
x
to
is equals
2k.
to k, probability that x is equals to some m. This will be 1 minus p whole to the power m minus 1. M minus 1 failures followed by 1 success.
Okay, failures followed by success.
Yes, yes, yes.
Correct?
Yes.
So we are getting the success in the mth time. That means m minus 1 are failure followed by mth time success. So
Yes.
here also the same thing. 2kth time we are getting the success. That means 2k minus 1 failures followed by 1 success.
1 success.
Plus 1 minus p whole power 2k minus 1 time, sorry, minus 2
Minus 2
times p.
Into p.
times p.
Correct? So I can take p
P
times
common.
p common and also 1 minus
also
p
1
whole
minus p.
power 2k minus 1 minus 2. 2k minus 2. Take 2k minus 2. This is smaller. This is
Yes,
bigger.
yes, yes.
Okay.
And this will be 1 minus p. 1 minus p.
2 minus p.
Yeah. This
2
here
minus
we will
p.
be remained with 1 minus p here.
Plus
And
1.
here we will be remained with 1. So when you take common, here we have 1 and here we will have 1 minus p. And this will be p times 1 minus p whole power 2k minus 2 times 2 minus p.
Sir?
Okay. Is there any option?
Sir?
Sir, second
Yeah,
last step, can you please?
this formula of geometric progression is okay, like 1 minus p to the power n minus 1 into p, right? But just just a couple of questions back, we discussed one more formula for GP, like 1 minus p to the power nj, right? So that was not clear. That was not so clear.
See, here it is equal to 2k.
Right.
That was
There it is greater than 2k.
Okay.
Okay. So that is why I said you write down explicitly. Explicitly, I mean write down each and every possible case, if you don't know the formulas. So here it is actually x is taking 2k value, exactly 2k value. What will be the probability? So when it comes to probability that x greater than 2k, it means x can take 2k plus 1, 2k plus 2, 2k plus 3 and so on till infinite. So there are many cases inside this. When it comes to this here, there is only one case, x is taking 2k.
Sir, if I start writing range of y, right, given by the function defined as x by 2 when it is even and x plus 1 by 2 when it is odd. So if I start writing range of y, then I will be getting 1, 1, 2, 2, 3, 3, right? Like this, right?
See, 1, 1, 2, 2, 3, 3, yeah. 1, 1, 2, 2, 3, 3. But writing 1, 1, 2, 2, 3, 3. See, writing 1 twice doesn't make any sense. Okay. This is
Because it's a set, right?
It's a set, no?
Set does not take duplicate
It
numbers.
doesn't get repeated value.
Okay.
It's not repeated.
Yeah. So it actually says that y takes value 1, y takes value 2. If you are writing 1, 1, you are saying that y takes value 1. And also you are saying the same thing again twice. Y takes value.
Yes. Okay.
Okay. Okay, so we are done with 2.4, I guess. So 2.5 is also kind of
The second last step, sir.
It's just like examples
Excuse
on
me.
functions of 100.
Hello.
I think 10th and 11th are physical. Video lecture number 10th and 11th
Hello.
are.
Hello.
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 So
Yeah.
second last step, can you please explain one more? Okay.
This thing. Here to here, is it?
Yeah.
Okay. So you see here, I write this particular term like this. So 1 minus p times 1 minus p whole to the power 2k minus 2 times p. Can I write it like this? Can I split this 1 minus p whole power 2k minus 1 as 1 minus p times 1 minus p whole power 2k minus 2? Can I?
Yes.
Right. Now this I am left with 1 minus. Now take this term also. 1 minus p whole power 2k minus 2 times p. Now we have this common and also this as common. So can I take common these two terms from these two? Can I take? So
Yes,
okay,
sir.
let us say this is q and this will also be q. Okay, we have 1 minus p times of q plus q. So what will be this? Can I take q common?
1
If I
minus
take
p
q
plus,
common, this will be 1 minus p plus 1,
which is 2 minus p.
which is 2 minus p. What is this q?
This is 1 minus p raised to 2 into k minus 1.
Correct? So the same thing.
Oh, okay. Okay, sir.
Okay.
Thank you.
Okay. So now that we came to an end, thanks a lot and
Thank
have a
you.
great
Shrikant, can you
night.
explain
I have a
GA one
question.
question for me?
Yeah, sure. So week 2 we are done. Today's
Okay.
live session we are done.
Thank you, sir.
So
Can
nothing
I?
to discuss from my side. Okay.
Hmm.
I
Whatever.
have. Sorry, please go on.
Yeah, whatever the topics we are left, we will try to cover it on Sunday. Okay.
Okay, it's on the next set of topics, but probably if you can give me a hint of something, I'll ask after you are done with. I mean, the rest of the colleagues are
Okay.
done.
Yeah.
But
Those
I would
who
like to
are
ask a
done, you
question on.
can leave. And thanks for joining.
Yes.
Have a great night. And I can take for some 10 to 15.
So Sunday you will be available?
Sunday we'll try to take the session because the very first week I should take the session, but Nikita has taken my session due to my personal.
Sunday is not scheduled in the calendar.
It will get updated tomorrow.
It is get updated, I guess. It will get.
It will update. Not yet.
Not yet. When in Sunday? What time?
Same time, I guess. 8 to 10. 8 to 10.
8 to 10. 8 to 10.
Okay. So even if I didn't take, I will tell my colleague to take from 2.5 lecture to discuss the topics.
Yes, sir.
Okay. And
thank you, sir.
What else? Yeah. Thanks a lot. And I can take some 10 to 15 minutes to very small doubts. Okay. Whether it may be week 1, week 2. So just the closing doubts. It shouldn't be like theoretical or big doubts.
Okay, I won't. I would leave it to you to judge whether it is theoretical.
Okay. Yeah, you ask me if it is possible to answer within this 10 minutes. I will take it. Or
sure.
Else,
I'm talking about this lesson 2.9, maximum of 2 random variables. Here, the discussion is more towards predicting the probabilities using a formula. And there seems to be some available formula like P of W is equal to W is where it starts and says W
Can
is.
you give me the time stamp exactly?
Timestamp, just 1 second, please.
Can you clear my GA question?
Yeah.
Meanwhile,
Sure. Yeah.
Can I read out the question?
Yeah, sure.
A fire coin is tossed 8 times. Let X be the total number of heads and Y be the total number of heads before the first tail. What is the value of f of Y given X equal to 2, 0? PMF.
Okay.
F of Fy given X equal to 2, 0.
Okay. So have they updated the solution PDF to you or?
Yes. But actually, when it comes to the 3 and 4 tosses, I'm easy to compute by writing head tail combination. That's so easy for me. But when it is 8, 9, 10, 16 like that, how to compute? Formula is given, but that is not clear for me.
I will tell them. We shouldn't give 3, 4, 5. They are computing with hands. They are writing down all the tables. No, see, that is why we are here to help you. You shouldn't do all that work. That is why we are studying this particular course, right? So it should be
Okay.
easier to understand. And in future, what we do is we don't even do these things. We just input to the computer, it will give us the output.
But you will test, right? Finally, in the test, we have to pass. Later on, I will enter that only, I know.
Okay. Okay. So a fair coin is tossed how many
8 times. 8.
Okay, now it is tossed 8 times. Okay.
X is the number of heads, total number of heads.
X is the total number of heads. Okay.
Y be the number of heads before the first tail.
Number of heads
Before the first tail.
before the first tail. Okay.
What is the probability of F Y given X equal to 2, 0? PMF.
Okay. Probability of Y.
If Y given
X is equals to 2.
0. X equal to 2, Y is 0. Y given X equal to 2, 0. Yes.
Okay. It is telling me, it is asking me the total number of heads are only 2.
Yes.
And also the first
Is the
time I
tail.
toss this tail.
I'll get tail. Yes.
Okay. Yeah. So that is what we have to find. This is actually F. You use the conditional distribution.
Yeah. Fxy 2, 0.
Fxy
2, 0 by
0
divided by f of x2 marginal PMF, right?
Correct. So what will be Fxy of 2, 0?
That's what when 4, 5 are there, I'm easy to note down.
No.
Here given in the solution, it's given. It's the Fxy 2, 0 is equals to Fx given y equal to 0, 2 into f of marginal y of 0. They computed in
They
that
have
way.
turned it out. So
Yes,
what they did is they have again it is
X,
we know this, right? Joint is
yes,
nothing but the
X is
product of
conditioned on y. Yes, they took X is conditioned on y equal to 0, y equal to 0, 2 into f of y 0. Here my doubt is f of y 0. How they computed f of y 0, I'm unable to get.
Acha, how this f of y0 is computed?
Yes,
So
they
what is
gave
that?
1 by 2. They gave it as answer 1 by 2. Fy0 is 1 by 2.
Okay. So what is y? Y is actually a random variable. It is actually counts the number of heads
Before the first tail.
Correct. So
Yes.
y can be 0, 1. You write the range first.
Till 8. Till 8.
No. Yeah, till 8.
In the question it given, yeah. If
Yeah,
no
till 8.
tail, then it is 8. Yes.
Okay. So till 8 is the range of y.
Yes.
So what we want is the PMF. First and foremost thing is we try to find the PMF. So what is the distribution of this y?
Uniform.
Uniform. No.
Oh, sorry. This is
actually we
the
are
tail and head is by Bernoulli.
No. Y. What is y? What are we looking at y? Number of heads before the first tail.
First tail.
Okay. Yeah, this won't follow any distribution.
Yeah, that's what I confused.
Yeah, this won't follow. I thought it is
X is a binomial, but y.
So we want Fy of 0. Fy of 0 means first one is tail and remaining we don't know. See, that is what we wanted to compute, right?
Yes, yes.
So yeah, getting first one is tail is what this tells you, right?
That's a Bernoulli, right?
It's a Bernoulli. Independent of whatever the next things are, this Fy of 0 is actually the probability that the first trial, first toss is a tail. Did you understand this? So whatever
Yes,
may be
yes.
rest of the things, our first
Mm.
toss first toss is tail. If my first toss is tail, my y takes value 0. Correct?
Yes.
So what is the probability that y is taking 0, which is equal to the probability that the first toss is a tail? So what is the probability that first toss is a tail?
That is half.
1/2.
Half.
No, actually, my doubt what is Srikanth, but marginal PMF, till now we are computing y0 is fixed and we are taking x as 0, 1, 2, 3, 4, 5, 6, 7, 8, and we are summing up, right, all the marginal PMFs. See, now the denominator fx2 is the marginal PMF, right, in the
Marginal
equation.
PMF of x.
Fx2. Then what I will do, 2, 0, 2, 1, 2, 2, what are the possible cases I will take and I will sum it up. That is the marginal PMF, right?
Yeah, 2, 0, 2, 1, 2, correct.
Whatever possibility it will go till 2 to 8, I will do and I will sum it up. So if y of 0, why are we not doing that?
See, because that is what the idea is. See, you don't need to go to x and everything. Just read the statement what y is saying. Y is actually the number of heads before the first tail. That is why we didn't ask you y is equals to 1 or y is equals to 2 or y is equals to 3. So if it is that the case, then that would have been a different scenario. Okay, then you should be looking at the possible combinations.
Because till now, whenever marginal PMF, when I see marginal PMF, I am following that method only.
You are
right?
following this thing, right? If fy of 1 we
fixing
ask
y,
you,
fixing y and
yeah.
varying x. Yes, whatever
Varying
possible x
0,
will
1.
come. Yes.
Yeah, 0, 1, 1, like this, right? You are trying
Yes.
this.
Yes.
And so on. However, how much the range of x is?
Yes.
Till the range of x. K1.
Yes.
Okay, you can do that.
If I do that for fy0, if I take one head will also be two head will no, it won't be.
All the sum will be 1.
0 is the yes.
So, if you take that case, okay. If this is
X is the total number of heads.
1, 0. So for that you need to know this joint distribution. No? How will you get the joint distribution?
1, 0, right? 1 means one head and there is no head before one tail. That is not possible.
One head.
One is total number of heads.
Yeah,
one is total number of heads, and 0 means there is no head before the tail. That means after tail. That's what I confused.
Okay, you should take more combinations. So in order to compute this itself, you have to go through like this. First one is tail, and second one may be head, and remaining all are tails. This is one combination. Plus first one is tail.
There are many.
Head. So one head you should get. So that can be in the second, third, fourth, fifth. There will be some 7 cases here itself.
So with the 3 or 4 tosses, I computed and I'm getting the correct answer. But when it comes to this 8 case, I'm unable to understand how this 1/2 came.
No, this is okay. For this particular question, this is not the approach. So you see, you should understand why we gave you y taking value 0. Okay, even if it is y is 1, we are telling that there is one head before the first tail appears. So that means first one is head and the next one is tail. This is the
that is also 1/2 only.
This is not 1/2, I guess.
1/4.
Getting head in the first place and getting the tail in the second place. 1/2 times 1/2. This will be 1/4. So you see, you should get head in the first place. This should also be fixed. And next one is like second case, you should get tail. When I say fy of 3, y of 2, you should have 2 heads before the first tail.
Yes.
Okay, so that means head, head, tail. Correct? This is how it goes.
I really confused with this.
See, you understand like this. So when y is 0, your first one is tail. When y is 1, the second one must be tail and the first one must be head. No other possibility. And when y is equals to 2, first 2 must be heads and the third one must be tail. No other case possible.
Okay.
Okay.
Is
So
there any other way to solve this problem for more number of process?
So. See, this is also my process. I don't know what solution you got.
Okay, fine. Okay, Srikanth, thank you.
Okay, yeah, you should read. Sometimes numbers also matters. That is why I said you should play with. You should look at the numbers. So maybe you got 8 in that starting place, but when we give you y is equals to 0 or y is equals to 8, 8 is also the end point.
Yes.
Okay, so if you have given you the end value, then there is something you should start from looking from the basics. You shouldn't be directly sit for calculations. You should somewhere, we should actually look at the question twice or thrice, and we should actually bring our complete brain into this question, and then we should work out.
Okay.
Okay. Yeah.
Okay, Srikanth, thank you.
Okay, thanks.
Yeah. Can I refer to the timestamp? It is 3.53. 3.53 on video 2.9.
Just a second. Video 2.9. .53 is it?
Yes, 3.53.
Okay.
So here W of W, if a probability has to be found, then there is already expression there, W minus 1 by n square. So where does this expression come from? Like, do we derive it or?
No, you can actually compute it.
Okay. Like this. We write down the series and then do it, or how is it?
So that is how this will be like. See, he has taken till n plus 1, and from n plus 1 he has taken from n plus 2 to 2n.
I mean, that is where I'm having my questions actually. If the range of x and y itself is limited to n, what am I doing with n plus 1? It is because of only x plus y?
It is x plus y, right? First write the range of w. What will be the range of w? It will be from 2 to 2n.
Yeah, that's correct.
That's
both
correct.
of them are at 2 to 2n. Yeah.
Yeah, 2 to 2n. And you see, probability that w taking some value which is less. Okay, let me just. Are you seeing the screen? Which screen are you seeing? This writing screen or?
I'm seeing the writing screen.
Okay. Okay, I will compute one thing. The above one, you try the below one.
Yeah.
Okay. Yeah. So let's see this. When w is equal to some w, small w, this means x plus y is equals to small w. Correct? The sum is equal to small w.
Yeah.
This particular big W, I'm just replacing it with x plus y.
Yeah. Okay.
Now, probability that x plus y is equals to w is nothing but probability that x is equals to some k and y is equals to some w minus k. Is it okay?
Actually, I'm not really good with these expressions.
Okay.
So, can I actually can I try my interpretation? After that, you can correct me. Feel free to correct me where I am.
Sure.
In the first thing that you rounded off, x plus y is equal to small w. When you say this is where I am actually having the variables x and y.
Variables x and y. Yeah, correct.
Variables x and y. Then why am I using the capital X and capital Y? Why not the small x and small y?
See, small x and small y actually represents the values that these random variables x and y takes.
Okay, because I'm putting the entire range of X and Y, I'm actually keeping them as capitals, is it?
Capitals. See, this particular capital X can take any value.
Right.
This particular capital Y, it can take any value, but the sum is small w. And again, this is a value. Small numbers are values.
Right. Okay.
Okay. Big capital letters are small letters are values. Capital letters are random variables.
Capital letters are random variables.
Random variables. Okay. So it's like, okay, let's say even I remove w, I say 3. Okay, now you will get small clarity. Okay, I want to compute the sum is equal to 3. Okay.
Right.
Now what are the possible chances when my x takes when my tx and ty are 1, 2, 3 and so on? When will be my sum will be equal to 3?
Sum will be equal to 3 if it is 1, 2 or 2, 1.
2, 1, correct. So when x is equals to 1, at the same time y is equals to 3 minus 1, or when x is equals to 2 and y is equals to 3 minus 2, correct?
Why do I need to write 3 minus 2?
I will tell you why are we writing 3 minus 2 and 3 minus 1. I will tell you. See, this is actually y is equals to 2.
Yeah.
Why we are writing y is equals to 2 directly? When you write x is equals to 1, how are we writing y is equals to 2?
Because 1 plus 2 is 3 and that is what we are aiming for here.
See, 1 plus 2 is equals to 3 is same as saying 1 is equals to 3 minus 2 or 2 is equals to 3 minus 1. Correct? In order to get the value of y, what we are doing is we are actually subtracting 3 from the value we are taking for x.
Okay. Yeah.
Correct?
Yeah.
So the value of x is equals to 1. If I fix that value of x is equals to 1, then definitely my y value should be 3 minus of the value taken by the x.
Correct.
So this is nothing but equal to 2. And similarly, when x is equals to 2, in order to be the sum to be 3, if my x is equals to 2, then my y value should be 3 minus of the value taken by x.
Yes.
Correct?
Yeah.
So now look at carefully how I wanted to write it like this. Combinedly, summation k is equals to 1 to 2, probability that x is equals to k, small k, comma, y is equals to 3 minus k. Can I write it like this?
Yeah.
Correct. I'm just writing this particular thing in this k in terms of case.
Right.
Correct. Okay. So now let us replace this 3 and 1s and everything with small w. Okay, I'm just replacing. See, even the small w is also one value. We don't know the value, but it is a value. Now I am replacing this with w. Sorry. Now this is 1. Okay. Now here, no, don't look at here. Look at here. I replace this with w.
Right.
Now my range should be, what will be my range of k?
Your range of k should be 1 to small w. Sorry, w minus, here it is x minus y actually. Sorry, w minus 1. Yeah.
Correct. See, when it is 3, here we are summing it till 2.
Yeah.
When it is w, it will be w minus 1. So this is summation. So this particular p x plus y is equals to w is nothing but the summation of k is equals to 1 to w minus 1. Probability of x is equals to k, comma, y is equals to w minus k. Okay.
Yeah.
Also, it is given that they are IID samples.
Yes.
Okay. When they are said to be IID samples, this is the joint.
All of them are the same value. When I say, okay, IIDs means they are independent of each other. So
yeah, they are independent to each other. Their joint can be written like this.
Multiplication of the two.
Yeah.
P of X minus.
Correct?
Yeah.
Also, it is given that XY are IIDs uniform 1 to n. So when they are uniform 1 to n, what is the probability?
Uniform 1 to n, it's 1 by n.
Correct. One by n. So this is 1 by n, and this is also 1 by n. We are summing up till 1 to w minus 1. So 1 by n square plus 1 by n square plus and so on plus 1 by n square till how many times?
It's going to be.
See, this is 1 by n.
Yeah.
This is also 1 by n.
1 by n.
What we got is summation k is equals to 1 to w minus 1 1 by n square. So what we have to do is irrespective of k. So now this is independent of k.
Yes, power w minus 1.
Yeah, w minus 1 times.
Yes.
So this will be w minus 1 by n square. So that is what it will be in between 2 to n plus 1. So when w is still n plus 1.
Very neat.
Okay.
Very neat. Yeah.
Okay. Now
yeah.
you try for what if w value is greater than n plus 2?
Yeah, this is where I want to have. I mean, I'm scratching my. Okay, this derivation. Thank you very much. This is very nice actually.
Okay.
I'm able to understand it better. But why do I need to go for a split? Is what I have not been able to get.
See, yeah, split you have to go because see here, you see x. This is x is equals to k. So this particular k can always takes in between 1 to n. It won't go beyond n. So whatever the thing we have seen, this particular w or w minus 1 is pretty straightforward. Here you see this k will never, this w minus 1 will never go beyond n or beyond n plus 1.
Okay, I'm not able to see what I'm using my mobile for this call, so I'm not able to see which one you are pointing.
You just do one thing, okay?
Yeah. Yeah.
Tomorrow morning or maybe tomorrow evening, when you got the free time, just open a YouTube session of this.
Yeah.
Come back to this.
Yeah.
And you watch this again.
No. What I mean to say is what you are pointing. You said you see something, right? I'm not able to see that. Is what I'm saying.
Oh.
Okay. But this derivation, yes, it is. I am clear about the derivation part.
Okay. So, Acha. So this is the derivation. Oh, Acha, you want you to know why we are splitting?
Yes.
Okay. Why is when w scale w yeah, okay. See, here k is running from 1 to, here k is running from 1 to w minus 1, right? Hello?
Yes.
Now see, if I didn't split, so how can I write this? If I wanted to write it explicitly, how can I write this? Probability that x is equals to 1, y is equals to w minus 1 plus probability that x is equals to 2, y is equals to w minus 2. Correct? This is how I will write, right? Probability that x is equals to w minus 1, comma, y is equal to 1. So this is how I write. Suppose if my w is greater than n plus 1. Okay.
Okay.
Something like n plus 4 or something.
Yes.
Okay. Now see, if my w is n plus 4, if I substitute it here, y is equals to n plus 4 minus 1.
N plus 3.
N plus 3. Can y take value n plus 3?
Y take a value of n plus 3? No, y cannot take a value of n plus 3.
N plus 3. Till n only it is defined.
Correct.
Correct. So if my w is greater than n plus 1, few terms will be 0. So this is actually 0.
Yeah. By definition, all the terms will be 0, no?
No, not all the terms. So few terms, what happens is this will be like x is equals to some 5, comma, y is equals to some w minus 5. Here what happens is x can take 5 as well as x can take
0.
Something in less than n.
Yeah.
Not every term inside this will be 1 by n square. Not here few terms will go 0. Okay. So excluding those, the sum will not be w minus 1 by n square. That will be something what professor has written. Okay. I suggest you to try this. Okay. How many terms are getting 0 actually?
Okay.
It is actually, you see, if you see that 2 by n minus w minus 1 by n square.
W plus 1 by n square.
If you split it.
Yeah.
If you split 2n and w plus 1. If you take minus common, you can see 2 by n. We are actually subtracting the above probability from 2 by n. So just identify why we are subtracting that. So we are actually subtracting few things, and we are
there's an overlap.
Maybe might be overlap. Just try it like this. So whatever the approach we discussed, you just try it. If not, you can come back and anytime you can ask us.
Sure. Even if I figure it out, I'll come to verify my thinking with you.
Sure. Definitely. You can come back. You can ask us. We will.
Is there an email ID that I can reach you at?
There is, I guess. It's in portal.
No? Sorry.
General instructions.
No. Which portal are you referring to? Are you referring to the discourse thing?
Seek portal. No. Our mail IDs are not there. Okay, you can reach out to that MA 1004. That official statistics ID. Do you guys have that? So how are you reaching us? Like, if you have any doubt.
Actually, no. Vishal actually gave me his email ID, but I have not been able to get back to him. As in, we communicated, but after that, I have not been able to make contact. He said, call me, but I didn't know how to call. Gmeet or something. I don't know what exactly is the protocol there. So it's all stuck there wherein I have a doubt. I'm not able to, reach out. So I would like to establish a procedure or process for myself so that I can, of course.
Okay. We can do one thing. So I will be answering in discourse. Even there you can get my email, or else it's like venkatesan@onlinedegree.iitm.ac.
Can you spell it out, please? Venkatesan or Venkatesh?
Can you see my screen name?
Yes.
It's the first word.
I see
participants list is there, na? Participants
list. You can click on the participants list and you can see my name.
Okay, Venkatesan. Okay.
@onlinedegree.iitm.ac.
Okay. Thank you.
Thanks.
And I have a doubt on the graded assignment of week 1. I'll send it across to you. Perhaps you can take a look at it.
We can I will take a look at it and maybe I will answer tomorrow.
Yeah.
Okay.
Thank you very much. Thank you for your patience.
Thanks a lot.
Sir,
Yeah,
would it be possible for you to take also on Sunday
for me it is
so that we
possible,
can
but
maintain continuity?
no, it's like it's already 2:35, 22:35. So you guys doesn't feel sleepy or?
No, not when studying with you.
Acha.
And anyhow, most of our sessions are now from 8 to 10 and they
Yeah, 8
always
to 10.
extend till 11 o'clock. So today we're going to be concluding a little on time. So it would be really nice if you could also take it on Sunday. We'll be really looking forward to that.
Which one?
On
The
Sunday.
session on Sunday.
Oh, me?
Yeah.
Oh.
If you
Okay.
could take.
See, we'll try definitely, because I missed one session. I should take one more session. I should compensate that session.
Please do.
Okay.
Please.
So maybe later weeks also we can discuss. It's not
Please,
like
please try to arrange a revision session before quiz 1. It should be there, right?
it will be there. Need
Sure,
not worry about that. But the way in which we deal the revision session might be different from what we did in foundation level. This was already I said you, right? See, when we are in the first term, it will be like we actually hold you.
Hand holding.
Yeah, hand holding, and we will move forward. And later on, you should try to walk at least in these terms. And in later diploma courses, you should actually run without us.
Okay.
Okay, we will sit and we will.
No, actually, why I'm asking for revision session to clear the concepts, especially.
Sure. Definitely, there will be a revision session. Definitely, the revision sessions are more of slided towards the quiz topics. Those all will be there. Need not worry. Okay. To get there, what I said earlier in the session also, please follow those. So try to understand something a day. It may be of 2 minutes or 3 minutes. It doesn't matter.
Because the syllabus is huge. Statistics syllabus is really huge. So if you arrange revision, that will be a quick glance.
Correct. Those all things will be there. Need not worry about those things. But what I want from your side is you should work at least 5 minutes. I am asking only 5 minutes per day. Okay, it's not
Nothing will go for 5 minutes. Srikanth, spending 2 to 3 hours.
No, spending 2 to 3 hours without understanding, trying to get the answer is different from try to understand one topic clearly.
Okay.
Clearly. When I say 5 minutes, not literally 5 minutes. Just sit for some time. Just try to
And
learn.
that's where you're important. That clarity of a topic comes when you take a session.
No, the subject statistics is like that. However, we learn now. Whenever some question comes, it's really it uses our brain. It will become difficult.
See, okay.
I have a different question. Does it get, like difficult, or like, are we seeing really the complexity that's there in week 12, or is this only a prelude to what we are expected to face as weeks go by?
See, definitely we are not intended to scare you or something, right?
No. I want to be ready for what. I know you're trying to make it easy, but I just want to be ready for whatever it is coming. That's the reason.
To be frank, the actual statistics starts from week 7.
Oh, okay.
So there we actually deal with the parameters, distributions, data. So when a data is given to us, how will we test the data? Whether it is so the testing of hypothesis and everything, every statistics analysis we do in from week 7. So these are just the basic things which we need to know. These distributions among the distribution, among the random variables distribution, and among the random variables how the behavior, if it is independent, if it is not independent. So these are very basic things, very basic terminologies of statistics. So to understand those things, you actually need this.
Okay. So the distributions will there be more, or because I during the course of whatever I was going through, heard about this thing called Weibull distribution and all these things.
No. Yeah, I was actually referring to that bull or bell distribution, Weibull distribution.
Yeah.
These are all everything you don't get. Maybe you will get beta, gamma, chi-square.
Yeah. Okay.
Beta distribution, gamma distribution, chi-square distribution. That too on a very top CBC.
Okay.
Or we don't go in deep into that.
Okay.
Sir, a quick question.
See, main thing is like I guess you got some inputs from your senior batch or something like statistics is more difficult. So if you have that in your mind, then definitely you will feel even the easier.
One of us getting it, it's almost certainty.
Can you mute your mic, please? Whoever that is.
Okay. So
no, I won't put it that way because I have not made contact with anybody. Actually, I am a diploma student. It's been a while since I actually came out of college. Okay. So getting back to this is proving to be a little tricky. I'm trying whatever it is that I could. So
right. See, there are many. I guess even Sandhya, there is Divya. These all are the same kind of people. They left college at 10, 20 years, maybe, if I'm not wrong. Yeah, they are working hard. See, the thing is, if you left college, if you don't mind, I compare with some horses or such like that.
It's okay.
When horse is becoming old, or if it has been a while since the horse ran, so coming straight away into the field and running with the young energetic horses will definitely be difficult.
Yeah.
So what should that horse do? What is Dhoni doing right now? Even at the age of 40, how he is competing with the youngsters? So more and more practice in the nets, and so that is what makes him better, right?
True. This is where actually I am in a dilemma. Dilemma is essentially this, as the other lady was also mentioning, nothing actually is finishing in 5 or 10 minutes. I sit for 2 hours a day only on statistics. And as you said, one problem suddenly I'm able to solve. I'm like, yeah, this is nice. So what I'm trying to hint at is having to spend so much amount of time already on statistics and working. I would love to solve more problems on statistics, but I don't have the time. And even if I have the time, where do I get those problems from? I don't know. That's where I am. It's it's not even chicken or egg question. Where to start? I'll be eating myself if I am trying to do something. So this is where I am caught.
Okay. So I guess we have a reference book.
John Rice, John Rice is that. Yeah. There were 3 books. Some of them were pretty expensive, so I just went for the cheapest one that was available, John Rice. So,
is it not available in bookfee.net? See, just go to bookfee.net. You can get the PDF version of that book.
Bookfree.net.
Could you write that down?
Is my screen still visible?
Yes, it is.
So I don't know whether I can write this or not. This is an unofficial site.
Then spell it out, please. That will be better.
Bookfee.net.
Bookfee.net. Okay, got it.
Thank you.
That is an Chinese site or something. I don't know.
Okay.
But most of the books you can get it from there.
Okay.
But actually, our AQ, PA, these questions are more than enough, no? These are more.
See, even tutorials. You have tutorials, right? You can practice.
Yeah, we have many questions.
No, the problem, you're right. The problem is not about not having questions there. As we have been discussing, and you also, I think, pointed out a little earlier, you were asking about how to solve this question, how to solve that question. So solving doubts with one set of questions is okay, but implementing what I know for the other questions also has to be there. No? That is where I'm actually stuck.
See, for that, I guess you need to be strong in basics.
Yeah.
See, if you are able to solve one particular question, and if you are not able to solve another type of question, then your basics is lacking.
Correct.
Not the question.
Yeah, exactly. That's what I said. I am trying to see from the whatever I'm understanding from the videos, I'm trying to actually connect to the problem, and that is not happening. So I make my mistakes, and then I understand what is there in the video better.
Mm-hmm.
That's, I mean, you ideally are suggesting it to go from theory to the problems, and I'm obviously having a problem, so understanding the video. So I'm trying to come back from the problems to the video. That's all. That's all is happening. That's the reason why it is taking a lot longer.
Maybe that's not a better idea. Just rethink about.
Yeah.
Just give time, rethink about
Try
it.
to watch these videos. These videos are enough for statistics.
No, Professor, when he's actually explaining, I love the explanation, the way he says, the language he speaks, and the confidence that gives, saying this is nothing but you just do this and all that. But when it comes to a problem, I feel like I'm thrown into a tiger cage. And that is where I actually am feeling like.
Actually, what we have to do now, when a PMF question comes on our own, we have to create the table, whole PMF table, and we should match it up whether it's coming to 1 or not. In that way, we will cross check. If we do for one question, now our concepts will be clear. When it comes to the joint PMF, marginal PMF, and when conditional PMF comes. In that way, we should, when we approach in limited time, we will clear our concepts.
Yeah.
Instead of solving plenty of problems, it is better to solve a few problems which covers all the concepts. That I feel better.
Yeah, you are right there again. That is what I would actually do if I were a little younger and everything. The problem is,
hi, can I ask a question?
Yeah, please go on.
Yeah, hi. I am left college 20 years back and now trying to join back. My question is so can you please briefly say as to when are these sessions happening online, so that
that's there in the calendar, right?
Have you enrolled to that calendar?
Yeah, I know the calendar, but more or less Fridays, I understand is going to be one session, and the other days, sir, if you can.
Sunday and Tuesday.
And these happens in the evening or in the morning?
Evening,
8 to 10.
Oh, good. Tuesdays, Sundays, and Fridays. Right. Thank you so much.
Tuesday is 6 to 8. Tuesday is
6 to 8. Yeah. Correct.
Okay. Thank you.
Thank you, sir.
Okay.
Thank you, sir.
It's a general discussion. I think I'm holding you up.
Yeah, okay.
Thank you.
What I suggest is, if you are watching a lecture, right away do the AQs and write it somewhere. Do it in a good book, okay? Don't be like take a paper, throw it away in the next day.
Oh yeah, I tried that, and I come to a book about last week. Sunday, I realized this is not working, so went and purchased a book, and I'm doing that.
Correct. So whatever you understood from the lecture, write it down.
Yeah.
Once you finish the lecture, straight away go to the AQs, try to solve it using the lectures, what you have listened in the lectures. Just try to use it and try to solve the AQ. When you are solving it, keep it in a note. It shouldn't be like a throwing paper or something else.
Yeah.
Okay.
Yeah.
So more of practice and more of writing your own notes will give you much more clear ideas about this.
Yeah, it definitely is helping.
Yeah, and also I am mentioning it again. Statistics you definitely require if you want to become a data scientist. Okay. So this is one pillar, maybe you can say.
Excuse me. May I
build it with proper cement and bricks.
I too have one doubt to ask. Actually, I'm still from a higher group, and I too have a problem in these lectures. And the major thing is that normally I am able to solve the activity questions, but I find difficulty in solving the graded and practice. So where is it lacking?
Great. See, in practice, what happens, practice questions are like interconnection of lectures. So in AQ, we will just give what that lecture is on, and we can only give questions based on that particular lecture.
Okay.
But in practice, what happens, we can combine 2-3 lectures and ask in one particular question.
Yeah.
Okay. There you have to identify first on which topics this question is based on. So once you identify, try going back to, see, that is why I say you write a short notes when you watch the lecture. You don't need to go back the lectures again. You just open the short notes of yours You just refresh, you just read it again, then you try to solve that practice problems. Okay.
Is there any book for revision of basics? Because I'm finding the Stats 2 course a bit difficult as compared to Stats 1 or Maths 2.
Okay. For basics, you are asking. Say, can I tell this in the next session, or I will ask?
Okay. So equally okay.
Sir, one very basic question, sir. Very small question. I'm feeling everything like binomial distribution, Bernoulli distribution. Everything looks very similar, and when I'm seeing lecture, it is okay. When I'm going to apply somewhere, and it is very confusing actually. Is there any minute difference between all these things? And
see, can you open? Okay. See, there is a minute difference between these things, of course, because the name itself you should understand. If all are same, why we keep those many names?
Yeah, but same sir, like independent, like in binomial distribution, we are summing up what are all the individual events when it is happening, and in Bernoulli we are multiplying things.
Bernoulli multiplying things.
Multiplying that probabilities.
I think you mean the binomial.
Yeah, in Bernoulli we are doing, and binomial we are adding all these things.
I didn't get Bernoulli. What are we multiplying Bernoulli?
Bernoulli is a single event thing, so you won't multiply anything. It's either the probability of happening or probability of not happening. So binomial would be the same event being repeated multiple times.
Okay. Have you attended Sunday's lecture, which was taken by Nikita? She explained distributions somewhat clearly.
Yeah, she did. She did actually.
So just go back.
Yeah, I didn't attend it.
Just go back to that lecture. Just watch the difference between all the distributions. Okay. She explained it with an examples also.
Okay.
Okay. It was of 2 hours of lecture, so you can watch it. So all the 2 hours, I guess, she spent on dealing with these distributions.
Thank you, sir. Thank you.
Go back to it. Okay. Thanks.
Thank you very much. Thank you very much, Srikanth. And have a nice evening. I'll log off now.
Yeah, sure.
Very much.
Same to you. And
thank you, Srikanth.
Yeah,
good night.
Thanks.
Bye-bye.
Good night is a better option.
Yeah. Good
Thank
night.
you. Bye.
Thank you very much, sir, for the wonderful session.
Thanks.
Excuse me, sir.
Yeah.
Sir, this free website is getting some.
Bookfee.net.
Welcome. Yes, sir. Bookfee.net. Welcome to Engines on Debian.
Welcome to
Engines on Debian page.
You want? You are asking whether that book is there or not? Is it?
I'm trying to search.
Acha, is it not there in that?
No, sir. I'm getting some.
Okay, maybe there is some other site. Can I tell you it in the next session? Apart from bookfee.net, there is another site where you can get, I guess. Is it okay?
Yes, sir.
Right now I can't recall. Maybe in the next session I will come up with name of the site. Okay. Or else I will come up with the book which is available and which is very decent to start from the basics. So either of this I will come up. Okay. Okay, Chanakya.
Yes.
Okay. Yeah, why are you so dull? Are you sleepy or you are?
I'm actually problem in my throat. I'm actually fever and suffering from fever.
You are actually feeling
suffering from fever.
Oh, then why did you attend, man? Your eyes will pain, right?
Yes. No, sir. I'm actually having sore throat.
You are?
Sore throat. Problem in throat.
Okay. कोई नहीं. Take rest. Okay.
Thank you, sir.
Okay. Okay, chalo bye.
Okay, sir. Thank you.
Everyone.